Welcome to ECE 111, Introduction to ECE. In this lecture, we'll go over the syllabus and introduce you to the course. Now, the first question you might ask is, what is electrical engineering, computer engineering, and software engineering? Those are 3 degrees offered in ECE department. Well, electrical engineering, one way to think about that is pretty much devices that use electricity, which are electronics, filters, interfaces to computers, toasters, flashlights, you name it. It may or may not include a computer. And you don't have to have a computer for everything, but computers are just darn useful. So you're seeing computers appear everywhere. Even light bulbs have computers in them now. A computer engineer is an electrical engineer that does design systems that have a computer. It's basically software and hardware tied to a computer. In programming, there's actually 3 levels of programming. The computer engineers typically do the low-level programming. That's where you read the sensors, you drive the actuators, read and write to the actuators or the registers. That low-level programming, that's computer engineering. Mid-level programming is, you might think of something like the Arduino Raspberry Pi. Somebody wrote those low-level routines already, and I'm going to write calling routines. So mid-level programming, I might say, let's get a quadcopter to hover, and you'll typically have maybe 100 to 1,000 lines of code. Software engineering focuses completely on software. A little bit of hardware involved, but mostly software. If you deal with high-level programming, like artificial intelligence, getting a quadcopter to swarm, doing gradient search to find the gas leak in a field, that'd be software engineering. So this course kind of covers all 3 of those. In terms of why this course exists, there's actually 2 reasons. One of the reasons, if you look at the curriculum in the ECE department, you start out taking algebra, trig, calc 1, calc 2, and so on. You don't actually get into your major until your 5th semester, typically. We lose quite a few students in the first 2 years, and one of the reasons is that, well, the math is important, but the fun stuff is when you get into engineering. That's when you start building stuff. So we introduce a class in the freshman year just to let you know that engineering is a fun major. Stick it out. You got to get through the math, but once you do, it's a lot of fun. Second reason for it is we use MATLAB extensively. MATLAB is a computer program. Think of it like a calculator on steroids. It's a program that's customizable, which is why MATLAB really took off. It's become the industrial standard in engineering, and it's used extensively in our courses as well. Some feedback from our students is that it would be really nice if we had a course to teach you how to use MATLAB before we expected you to use MATLAB. That's ECE 111. So it's kind of a fun recruiting course that teaches you how to use a computer language, MATLAB. Now, the stuff we do in this class is we use MATLAB to solve problems similar to what you'll encounter in various courses. For example, when you take Algebra 1, you study how to solve one equation, one unknown. Stay tuned until you take Algebra 1 to see the techniques in that class. But using MATLAB, I can use numerical techniques. So for example, if I want to find out, if I have this curve right here, given the temperature, find the voltage. If I have 8 volts, what's the temperature? Well, I can read it off the graph. In MATLAB, I can iterate to solve. So for example, if I'm at 7.5 volts from the graph, I should be at right around 2 degrees Celsius. Well, in MATLAB, I can do that. I can write a thing called a script. This is a little routine that'll go through an algorithm to iterate, try to find out what the answer is. And as I run it, here's my first guess. Second guess is trying the temperature, finding the error. The temperature is actually 1.9489 degrees. That's this point right here. Well, that's one thing you can do in MATLAB. Second thing, when you get to Math 105 trigonometry, you study sines, cosines, trig functions. Well, one thing you can do with trig functions is, given a robotic arm, find the position of each link, find the tip position. Well, that's called forward kinematics. Given the angles, where's the tip? There's also inverse kinematics. Given the tip positions, what are the joint angles? You'll study that when you get to Math 105, but using MATLAB and numerical techniques, I can do the same thing. For example, here, Here's another little script that's basically the program that I'm trying to run, or the MATLAB code. I'm going to let the angles follow these functions and then draw. This is what the robot's doing as the angles Q1, Q2, Q3 vary. MATLAB also has really good animation. It's supposed to be a calculator, it's a number cruncher, but for a number cruncher, it actually does animation really, really well. So using some trig functions in MATLAB, I can calculate the tip position of a robot and plot it, given the joint angles. That's forward kinematics. In MATLAB, you can solve n equations for n unknowns. You can also do curve fitting. If I have a bunch of data and want to draw a line through that data, I can find the optimal line in a least square sense. And instead of just making up data, we're going to be using real data in this class. For example, this is the minimum Arctic sea area, the ice covering in the Arctic, the minimum for each year on a year-by-year basis. If I wanted to sit there and say, let's do a linear curve fit, I can do that in MATLAB and find that red line. From that red line, I can find the zero crossing and find out when is the Arctic going to be ice-free. I can do stuff you cover in calculus. When you take Math 165, you'll cover differentiation. That's using, well, find the derivative or slope of a function at any given point. Well, using MATLAB and numerical methods, I can also find derivatives. And what I can do is if I have a robotic arm, like that last slide, if I want the first angle to go from 0 to 1 radian following this path, what does that mean in terms of voltage and current to a motor? Well, the voltage is roughly the first derivative of angle. The current is roughly the second derivative. So if I want to follow this path, that's the voltage that I need to apply to the motor, roughly. And this is the current that I need to apply. When you get to Math 166, you cover integration. With integration, you can solve differential equations. For example, this is a 10th order coupled differential equation, coupled first order differential equations, also known as the heat equation. Using integration, numerical integration, I can sit there and show this is the temperature along a metal bar as I vary the base temperature. If I have coupled second order differential equations, I can integrate, and what I wind up with is something called the wave equation. If I vary the temperature on the left, or the position, I launch a wave, and the wave propagates down. This is using MATLAB and numerical techniques to integrate and solve the heat equation, solve the wave equation. So those are some of the things we'll be doing in MATLAB. Basically, MATLAB is a really useful tool. You can solve all sorts of problems with it. What we'll be doing in this class is we have 16 weeks, meaning 16 topics that we're going to cover. We'll cover 16 different numerical methods you can use in MATLAB to solve problems similar to what you'll see in various classes. Now, if you're interested in how to solve these problems by hand, stay tuned until you take those classes. The emphasis in this class is how to use MATLAB. Using MATLAB, you can solve all sorts of problems. Even if you know nothing about how to solve it by hand, I can still solve them using numerical methods. It's that powerful of a tool. So that's kind of where we're heading. As for some course information, I'm Jake Lauer. Class meets on Tuesdays. It's also live streamed on Zoom. It's also available on YouTube. The recitation is on Thursdays. The recitation is really a computer lab. It's a lot easier to have somebody show you how to use a computer language like MATLAB than having to read the manual. That's what the Thursdays are about. We'll talk about that a little bit later. My office is ECE 201. Office hours are Monday, Wednesday, Friday, 8 to 9:45, in person and on Zoom. In terms of the bulletin description, it's an introduction to electrical computer engineering, problem solving, basically MATLAB. By the end of the semester, you should know what courses you need to take to graduate in electrical or computer engineering. You should be able to solve problems from various areas of ECE using MATLAB, and you should be able to use functions of MATLAB, including plotting, creating M files, and writing scripts. Now, this course is offered in the HyFlex mode. What that means is you can take the class any way you like. You can take the class in person. There's always plenty of seats in the lecture hall. If even if you signed up for online, you're welcome to attend in person. You can live stream the class. All classes are live streamed on Zoom, so anyone's more than welcome to join in on Zoom if you like. The class is also available online. All lectures have been recorded and posted on Bison Academy. How you take the class is up to you, and you can change on a daily basis. If you feel like showing up in person one day, you're more than welcome. If you feel like watching the YouTube videos the next day, that's okay too. Whatever works for you. However, in person is better than online. So just for full disclosure, I've been teaching for 32 years in person, online for 4 years. I'm better at in person than online. And that shows up in the course evaluations, that shows up in the final course average. So in person is almost a letter grade higher than online. Now that doesn't mean that online people can't get an A. Pretty much this class, if you do the homework, you do the MATLAB, you got an A. But overall, in person is better. So given a choice, I'd show up and take the class in person, but it's really up to you. In terms of the resources that you need to take this class, you need MATLAB. That's kind of the whole point behind the class, how to use MATLAB. MATLAB is free to use for all electrical computer engineers at NDSU. NDSU has a site license. If you go on Bison Academy, there's instructions on how to download MATLAB. That's under ECE 111 and resources. It's available for personal use and available in all computers in engineering. You're going to need a calculator that can do complex numbers. When you get to circuits 1, circuits 2, we live and breathe complex numbers. You need a calculator that does complex numbers by the time you get to those two classes. What you pick is up to you. I highly recommend the HP35S calculator. It's worth about 10 points on midterms. Prior to the pandemic, they were about 37 bucks. Occasionally get them for 20 bucks on eBay. Since the pandemic, they shot up to about $300 each. There's a free version of this calculator. It's the Free42 app on your cell phone. Just search Free42. That's the HP42S calculator. In my opinion, the best calculator ever built. You can actually buy HP42s nowadays, and what it is a cell phone where they disabled all features except for that one app. Or you can just download the app. Most students use TI-84 calculators. HPs will dust a TI when it comes to speed, but really up to you. Word of warning, however, HPs do have a learning curve, so don't try to learn how to use an HP calculator on the midterm. 111 is a good class to learn how to use an HP42. I'd recommend download the Free42 app, get used to it, so that by the time you get to circuits 1 and circuits 2, you have a calculator that does complex numbers that you're familiar with. In terms of the textbook for this course is Bison Academy. It's free. It's available to all current and former ECE students. It's also a good reference if you ever forget something. All lectures are posted on Bison Academy. Click over here. It's got a PDF file with the day's lecture. All lectures have been recorded and posted on YouTube. Here's the YouTube playlist if you want to invite your friends and neighbors over and binge watch, or the weekly lectures. If there's a handout or sample code in the lectures, I'll include them over here. And the homework sets. Now the homework sets are posted every week. Due the following class, the following Tuesday. I'll post the solutions on usually Tuesday or Wednesday, usually Wednesday morning. Homework is due before the solutions are posted because it kind of takes the challenge out of doing the homework once the solutions are posted. If you'd like some help on the homework, a good place to go is under Homework Sets and Solutions on Bison Academy. Here the homework sets and solutions from previous semesters are posted, both in PDF form as well as a YouTube video. And the YouTube videos were for the online students if they want to watch these solutions going over the homework. That's what the video is. So if you ever get stuck, please go here. The problems change every semester, so don't just copy and paste. But the procedure, the use of MATLAB to solve this type of problem, will be given, is available here. For submitting your homework sets, You can submit them pretty much any way that works for you. A hard copy works if you want to submit a hard copy in person. If you'd like to save a couple trees, you can submit an electronic version, upload the electronic version to Blackboard, or just email me. Your pick. Don't care. For electronic submissions, please use MS Word or a PDF file. Basically, if I can open it, I'm happy. Word works out really well for this class. With Word, I can use copy and paste, copy the MATLAB code into Word, and there's use of MATLAB. When there's an image, like a plot, I can do the snipping tool. I can copy and paste that into MS Word. Then you just submit your Word document when you're done. That's an easy way to do this class. Demonstrates I can solve these types of problems using MATLAB. Another place on Bison Academy are resources. If you want to know how to get to Circuit Lab, here's where Circuit Lab is located. How to download MATLAB, some HP calculator help. Scilab is a free version of MATLAB, which isn't really relevant since MATLAB is free for all ECE students. But once you graduate, you might want to switch to Scilab. And some data sets. We'll use the data sets throughout this class. In terms of grading, grading is 100% based on homework. So if you miss a homework assignment, yes, it will hurt your grade. If you give a good faith effort, try to do the homework, get it turned in, you should have no problem getting an A or B. Again, this is an introduction class. It's not a weed out course. The whole goal is to get you used to using MATLAB. If you use MATLAB, you do the homework, you should get an A or B with no problem. But if you don't do the homework, it will hurt you. So please do the homework. Also, this is a building course. The stuff that we do early in the semester is going to be used later on in the semester. So you kind of need to do the homework in order. In terms of the lectures, lectures are on Tuesdays. They're live streamed on Zoom, also recorded and posted in YouTube videos. And typically what we'll do for a lecture is pick one of the classes you'll be taking in the near future. Let's pick one of the problems that you'll encounter in that class and show how you can solve it using numerical methods in MATLAB. Now note that the focus of this class is using MATLAB. If you're a little bit fuzzy on the theory behind what we're doing or how to solve it by hand, don't sweat it. You'll be covering that when you take the following courses. Like you'll be spending 16 weeks on EMAG when you take EMAG. We're just going to look at, here's a problem from EMAG, here's how I can solve in MATLAB. Focus on the MATLAB part. And another reason for that is I kind of cherry-picked some of the more interesting problems you run into in these courses, trying to make this an interesting class. So it's not just using MATLAB as make work. These are interesting problems you're going to see over the next 4 years. That's the lecture. Lecture's on Tuesdays. On Thursday is the recitation. Now with a programming class, typically in programming, you can read the manual, spend hours trying to read the manual, figure out how to use it, or somebody can show you in 30 seconds. That's kind of what the recitation's for. In the recitations, we help you do the homework sets. Kind of show you the MATLAB commands. If you get stuck, I'm there, TA's there to help you. If you need help with the homework, please show up to recitation. And again, it doesn't matter if you signed up for online or in person. There's plenty of room in the recitation room. If you don't need help with the homework, recitation is optional. Completely up to you. But again, if you want help with MATLAB, please show up to the recitation. It's much easier on me, much easier on the TA. And we can usually get through the week's homework assignment in that hour and a half of the recitation. And finally, legal stuff. Attendance is required. How you attend is up to you. You can attend in person, you can attend via Zoom, you can watch the YouTube videos, whatever works for you. If you have any special needs, let us know, we'll accommodate you. In terms of academic honesty, the point behind academic honesty is that the stuff you use, the stuff you learn in these classes, you're going to use later on in the ECE program, and more importantly, you'll use when you graduate. Our graduates design defibrillators, pacemakers, flight controllers, engine controllers, things like that. If you figure out a way to get through NDSU without learning anything, please don't, because by the time you graduate, you're going to be really hosed when you get to industry. if you figure out a way to get through the early courses without learning anything, again, please don't, because you need this material when you get to be a junior or senior. Engineering is a building process. The stuff you learn in trig, we use in calculus. The stuff you learn in Calc 1, we use in Calc 2. The stuff you use there, you use in circuits. If you get through those courses without learning it, you're really stuck when you get to your junior or senior year. And if you're a veteran or student soldier, let us know. We'll work with you. So that's ECE 111, kind of an overview. Really kind of a fun course on how to use MATLAB. It's a course that I enjoy teaching, a course that I hope you enjoy as well. And with that, we'll be able to move on to the first lecture, how to use MATLAB.